Okay, so this is my picture, and I'm going to use the picture to illustrate to you how we could find this area. If I want to find the area between x squared and negative x, and I'm going to go from 0, which is right here, to 1, which is here, then this is what I'm talking about finding. I'd like to find this. So, how could we do that? I'm not sure I understood. So the entire block? What do you mean by the entire block?
So like from -2 all the way to +2 for the x. I mean +6, I think.
Okay.
Oh, +5 for the x.
Okay.
And for the y, it's just 2.
Okay. Oh, I see. Yeah, so you're trying to pull out all the pieces there. Okay. You probably get your answer that way. There's a much simpler way. Okay. So I think what you're trying to tell me is you'd find this piece.
Yes.
And then you'd add the other one.
Yes.
That'll work, but there's still a simpler way. Yeah, you're looking at the notes, right? But what are you doing? If you think about what you're doing, area goes back to little rectangles, right? Little tiny rectangles where this is the height, and this is the tiny, 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 almost not there width. So if that's the height, how tall are these rectangles here? If I was to give you a number, it would be the top curve here minus the bottom curve. And because I'm subtracting negatives, that's why it gets longer. But it doesn't matter whether it was positive or negative. Any situation you have where you're trying to figure out how big is this, you take the top number and you subtract the bottom number. And with us, we're just going to represent it with functions. So the way we would do this is we'd go from 0 to 1 of the top function, take away the bottom function. So if you want the area between two curves, all it did was change the height of your rectangle, and that's how you adjust it. So this will be the integral from 0 to 1 of x squared plus 2 plus x, which gives us x cubed over 3 plus 2x plus x squared over 2 at 0 and 1. So it would be 1/3 plus 2 plus 1/2. And I think, okay, I guess I'll do it. I can do this. So 2 and 5 out of 6. Okay, so that's it. It doesn't get tricky. It doesn't change. The area between two curves is the top curve minus the bottom curve. So your turn. Pull out the graphing calculator. What curve is top? What curve is bottom? You might be able to sketch it quicker without your graphing calculator. But see what you get here. 2 minus x squared and x. Find the area between those two. Sorry. In this case, it's bounded by. So, do you guys know what bounded by would mean? Stuck in the middle. So why don't we just look at the picture, since that word might be new for you, and then you guys can take off with the rest of it. So 2 minus x squared, and then the other picture I'm looking at is y equals x. So then if I take a look, the picture there is, that's probably enough. Let's just graph it. So there's that one, and there's that one. So the area that's bound is this area right in here. That's between those curves. So it's the same problem, top minus bottom, but because it's bound, they didn't tell you where to start and finish. That's your job to figure out what is this point and what is this point. Okay? This one you could do by hand, but some of them, it's about, I don't know, it's 50-50 usually. You're going to see that this is generally in the AP exam. There is a question that is a complete from our textbook chapter 6 question. this is part A that we're doing right now, and sometimes it appears in calculator, sometimes it doesn't, but it's about a 50-50 shot. So I would say you can try this one without. Okay. So if you're looking for bounds, what you're saying is, where are these two things equal? That's where the graphs touch, and that's what I'm going to rearrange. So I'm going to have, oops, sorry, I have a bad habit of freezing that. There we go. X squared plus x minus 2. So if I factored that, minus 1 and plus 2. So x could be equal to 1 or negative 2. So I'll trace in roughly what I saw from that picture on my graph. And there's those points at negative 2 and positive 1. So this is the area that I'm interested in here. And now I'm just going to integrate top curve minus bottom curve. So it's going to become the integral from negative 2 to 1. And the top curve is my parabola, 2 minus x squared, take away x. So that's, I'm going to use the graphing calculator. At this point, those integrals shouldn't scare you. It should annoy you more than anything that you have to do it by hand. So let's have the calculator do this part of it. You could, of course, use the zero or intersect method to solve if you were going to use your calculator. But there was a question there about whether it would be calculator or not. So that's how you do it without a calculator. Oops, sorry. Of course, my graphing calculator here is doing the one curve, right? It's not doing the area between two curves. It's not a built-in function. So what we have to do is go back and make this slight little change here. Top curve minus bottom curve. And now I can ask the TI-83, I can say, graph this baby and take its integral from negative 2 to positive 1. There. So 4.5 would be my area underneath the curve. Okay. So see what you can do with the area in one intersection of sine and cosine. So take a look at those graphs. It doesn't matter which one you pick. The graphs repeat over and over, but you have to pick one section and then find the area between those two curves for that one area that they're bounded by. So this is my picture, and then just to clarify, this is the area I'm interested in, right in between these curves here. It's bounded by the two. So how am I going to figure out where those two things touch? Yeah, where they're equal. So sine x has got to equal cos x. And maybe you recognize this one by now. Yeah, 45 degrees. If I divide both sides by cosine, I would get tan x equals 1. Then you can go back to your special triangles here. And this one you'd have a pi over 4. Opposite over adjacent is 1. So my reference is pi over 4. And that's what I'm seeing here as the first spot where they touch. And then that's the second spot where they touch. So if this is a tangent, it is positive here and here. So pi over 4 and a reference of pi over 4. So that means I'm going to have 5 pi over 4 on this side. So that's my bounds then if I'm looking at it. So I'll go back to my picture just so we can see it. This is pi over 4, the first intersection. This is 5 pi over 4, the second one. And this is the cosine graph where I'm tracing right now, and it's the bottom. This is the sine graph right here, and it's the top. So it's going to be sine minus cosine from pi over 4 to 5 pi over 4. And I'm feeling lazy, so why don't we just have the calculator help us out here. Let's say I'm feeling smart. Why would I do this by hand if a calculator could do it? So here's my picture. And I'm going to integrate it. Lower limit is pi over 4. And the upper limit is 5 pi over 4. So I get this nice pretty picture that shades. So 2.824, so we'll just call it 2.82. Okay. All right, so the last one here is for you to attempt with your neighbor. These are polynomials. What I would have you try is see what you can do with your graphing calculator, decide how much you can do by hand, but see if you can work out what's the area that's bound between these two curves. So there is a bit of a twist in this question. Does anybody figure out what the twist is? Well, 3 places, but there's a bigger twist than that. Well, they take turns being top and bottom, right? So sometimes it's the cube, sometimes it's the parabola. It means we need to separate this out into pieces. So let's just go through this thinking process here. I'll just do a quick sketch. It's not going to look pretty. I just something like that, and then the other one goes. I didn't say it would look pretty, but we're trying to find this area between those curves. So if I want that area, I need to stop right here. There's one spot where they change, so my integral is going to change. So this is what I'm going to end up doing is, you could solve this by hand. 3x cubed minus x squared minus 10x. Where is that equal to negative x squared plus 2x? There's a common factor here, so it's not as scary as it looks at the beginning. You're going to end up with, let's see if I move these things over, that's gone, that negative x on both sides. So I'll have 3x cubed minus 12x equals to 0. So 3x can be factored out. X squared minus 4 is left. So 3x, x plus 2, x minus 2. So I get these values, 0, negative 2, and 2. And I can use my picture to make sense of those values. Here's the one for negative 2, then 0. So I know my first integral is going to go from negative 2 to 0. And this is where the cubic is the top one. So 3x cubed minus x squared minus 10x. And then we'll take away from that the quadratic. That's piece number 1. And then piece number 2 is this one, which is going to go from 0 to 2. And this is where now the parabola is the top piece here. So this will be negative x squared plus 2x, take away 3x cubed minus x squared minus 10x. And I need to do those both in order to get the area between the curves. You can't do it in one shot because you don't always have the same top and bottom graph. So the message here is still the same. It's just that you need to look for your top minus the bottom. Same thing, it just switches to top minus bottom. So if you're ever unsure about what's going on in between area between two curves, draw the picture and consult. Which one's the top, which one's the bottom? I am not going to pull us through the mud to make us actually calculate that. I'll assume you're all quite capable of throwing it into your TI-83 at this point. Fair enough? Okay.